Good morning and welcome to the fresh edition of Frontiers of Knowledge. Long back, King Solomon said, "Go, thou sluggard, go and learn from the ants." So they were considered to be, the ants were considered to be, the epitome of hard work, dedicated work. Then they came to be understood as mindless creatures following one leader. And today they come in a new avatar. The world is facing an antibiotics crisis. Very powerful drugs are now useless against the strains of serious bacterial infections. And so, scientists are on hunt for the new ways to attack harmful microbes. And herein comes the one hated, admired at a distance species called ants. A very new study has highlighted how ants, even very small colonies, produce antimicrobial secretions. And their secretions have the chemicals which are antimicrobial. And those ants that don't make these secretions have some other mode that controls bacteria, and that's being investigated. Perhaps, quite possibly, according to the scientists, the one method of controlling bacteria is right under our feet. And that's also an answer to the antibiotic resistance. There are 12,000 species of ants, and they're as social as human beings are. We call man to be a social animal, and so are the ants. Their behavior increases the chances that come into contact with germs. Comparing the colonies of ants with our towns and cities, we find that they live a communal life up to the next level, with up to tens of millions of ants co-inhabiting a single nest. Colonies surviving depends on the worker ants going into the environment to collect food. And they return to the densely inhabited nest loaded with food, but also with harmful microbes. So, the returning workers, the returning working ants, share their foods and also their germs through mouth-to-mouth feeding. Because basically the process of an ant feeding is each ant vomits into the mouth of the others. If it was not enough, the warm, moist conditions in the ant's nest make them ideal nurseries for disease-causing microbes. Finally, all the members of the ant colony are related, and if one ant is susceptible to germs, it's quite possible that others would also be similarly affected. Despite the long-standing threat of the disease, ants are highly credible in resisting and overcoming bacterial infection. They dominate some environments and have diversified into thousands of species over 150 million years of their existence. They have found ways to deal with a high threat of disease. So why not learn from them? With their experience of 150 million years of combating antibiotics without taking any sin, mycin, terramycin, and others, they are resisting the disease. So how do they deal with the disease? That's quite interesting. Like humans, ants are extremely conscious about their cleanliness. They have very efficient waste removal systems, ensuring disease waste, including dead ants, that are removed from the nest and contained in special chambers. They regularly clean themselves and each other, and they group together to disinfect contaminated ants. The society as a whole combines. If there is one ant which is diseased, all other ants group together to clean it up, remove that contamination. But disease can still be an issue, however clean you may be. So ants have evolved around this, using their own form of medicine. Some ants, when infected, eat toxins like hydrogen peroxide to fight disease. Others collect conifer resins, which they incorporate into their colonies as a preventive measure. Some ants are able to produce formic acid, which combines with resin to manufacture a very powerful antimicrobial agent. And they also produce their own microbial agents in their bodily secretions, whether it's the stools or urine or perspiration of other saliva of ants. Each has microbial fighting capability. And now the Royal Society reports that Arizona University has investigated microbial activity of 20 ant species, and they are living in nests ranging from 80 to 200,000 ants. The larger nest species that produce effective microbials because they have more chance of coming in contact with disease. The smaller the number, the less the chances of the disease. The larger the number, because they co-inhabit each other, because they feed each other, practically, as I said, they vomit into each other's mouth. So one contamination spreads much more. Testing these external excretions against Staph epidermis, a common bacteria is known to cause it, shows that 60% of the ant species produce secretions with microbial activity. Surprisingly, the 40% ants don't produce this antimicrobial element. And what's more amazing is that the larger colonies are no more likely to have antimicrobial activity than the small colonies. So whether it's a small or large, the percentage remains the same. And disease, although it's more in the large colonies, the research shows that 40% of the ants without antimicrobial activity have other methods of controlling bacteria. And those methods are now being studied. So the question arises that in this age of antibiotics failing us, what are the antibiotics of the future? We started with penicillin, went on with tetramycin and all the sins. And the result is today we have the 5th generation of antibiotics. My doctor prescribed me 5th generation antibiotic. I looked at it and I found that it would cause severe nervous damage to my system, and that can be permanent in nature. So I refused to take it. I said, no, I'm not going to. If I have to die, I'll die. But I will not become prone to the disease of other nature which may not be cured at all. I purposely do not take medication until and I am convinced that there are no side effects. Our side effects are of such a nature that they can be counteracted. So, the situation today is if the fifth generation antibiotics can be that harmful to spoil your nervous system, and as long as the antibiotic resistance continues to increase, what is there to hope for? The sixth generation and the seventh generation antibiotic might be more harmful. But then you have got to fight disease. You have got to fight bacteria. You have got to fight microbes. So what to do? What is the antibiotic of the future that has no pernicious side effects? And these studies of Arizona University and the Royal Society show that ants could be a major contributor to the production of the new antibiotics that have no side effects and that can kill microbes as easily as any other potent antibiotic. Not only, you see, the point is that these ants not only produce their own antimicrobial agents, they also encourage other beneficial microbes to grow. So this is possibly the only animal species that in their body secretions produces antimicrobial agents. But at the same time, they are a catalytic agent, a good catalyst for the beneficial microbes to grow, which would be immune to the bad effect and would be helpful in fighting bacteria and microbes. The researchers have discovered that a bacteria living among one ant species that produces compound capable of killing harmful bacteria is resistant to all the conventional antibiotics, including the common superbug, MRSA. Now imagine that superbug is supposed to be immune to all antibiotics. There is no cure. And here the ants are producing that compound. That compound has not been produced in the labs by the scientists the world over. And the ants have been producing it and using it for the last 150 million years. So the human beings have to learn the art of producing that agent and maybe use ants for that purpose. The moment this fact was known, that superbug MRSA can be controlled by the compounds produced by the ants, was like a flash of good news. Let's not forget one thing, that millions of years of evolution in high-risk environment has enabled ants to become a vital source of very important, very potent antimicrobials. Now what we have got to do is that we have to convert the capability of the ants for human use or replicate the process that the ants are using in their bodies and replicate it in our labs and produce that antimicrobial agent. We have got to do and ensure that these substances produced by the ants are turned into effective drugs and then used by the human beings. But we learn about the strategies and that ants have used to fight disease, and that will enable us to uncover new ways to deal with the threat of resistant bacteria as well as overcome disease. Nature has produced one species of animals that are capable of their own self, use their bodies to produce antimicrobial agents, antimicrobial agents, and use them effectively even to kill the superbugs. And let's not again forget that they are living in a highly toxic environment. And if they can survive and be healthy, there is definite hope for man that these ants come as agents of salvation for the humanity to fight microbes, bugs, superbugs, and not have that drug resistance strain in our bodies. There is a hope. There's a light at the end of the tunnel. Let's see how it goes. Thank you.